just to wake you up. This is going to be a different talk than we have used to in the morning. How many of you use mobile banking? Good. Which validates the requirement was on the BBC News yesterday. Increasingly, we are becoming more mobile banking, which is what interested me to do this work. I did evolve a reference architecture, which is service-oriented. When the service-oriented applications started to emerge, I was a traditional software engineer, and I started to ask myself, where do I stand? And it was, even university teaching, as well as university applications. So I started to look at the cloud architecture and so on. It was too complicated. I know I graduated so many PhDs, but it's still complicated. So I started to ask myself, where is the simplicity of architecture? And we know the first principle of architecture is keep it simple. And that's how I evolved. And then it was for 10 years of work, which I published. I call it Software Engineering Framework for Service and Cloud Computing. And then I started to look at how do I look at my different applications. So I looked at e-government, and then the Fintech was one of the key interests that emerged from my own personal interest. So applied the practical value of architecture to Fintech, as well as the academic research, which probably we might end up in the future or already there. So I'll show you, I'll try and skip some slides which are maybe fundamental. So I will skip those. So that's the Fintech. So this is the key aim of this talk. The motivation is basically to the Fintech. Here the morning talks is more value-driven approach. And that value-driven approach, how do we integrate them throughout the life cycle? Again, for instance, this morning, I was amazed to hear that people have the same view. It's not that architecture is isolated, or it's not the requirement engineer is isolated. How do we integrate them across the life cycle? Which is what my main motivation. So we look at the framework which has been published, and there is a framework, the development process specific to cloud-based applications. So I did look at my 30 years of knowledge on software development lifecycle, and I came up with sort of mix of tools and techniques that might be suitable for a cloud-based applications. In other words, service applications. So I'll just briefly talk through the design principles. There's a new emerging trend, which is cognitive architectures, because we are more and more moving towards the 50 years of knowledge and experience. I can see where we are going, because we have done it for the last 50 years. There's so many expertise, there's so much on requirements, on the design methods. You can learn different methodologies, but where do you use them? Not every engineer is going to be educated in the 50 years of knowledge. So this is my another motivation. Why, even though I'm a software engineer, why I sort of started to evolve into AI, not in particular AI, machine learning, which has become mathematical based and has been quite now validated compared to some years ago. One way of this allows us, 50 years of knowledge, how we pass on to our generation. This is my main motivation. We can't teach them all, as children. So at least we can build that knowledge so they can use. So I took this traditional requirements process, for example. I'll give you the brief overview and then I'll show you the pictures. Now, 50 years of requirements process, if I look at the banking process, a loan application, simple loan application approval process. So there's a Dutch bank has publicly put down. Now, most of the companies now started to put their data open, which is quite interesting benefit of that knowledge that they have experience. I also worked in a bank for a little while, I must say. So, how that knowledge we can use if we are developing another loan process by another bank, and going there, the requirements are there. The requirements process are already deployed in a bank that they recorded their failure, success of approval, number of applications. Now how I can use that through machine learning process. I can look at my requirements and I can define it. So that saves my requirements time. This is where my motivation of moving into the machine learning techniques. So you can look at the Fintech. I might skip the traditional modeling, feature-oriented modeling, and so on. That's the predictive modeling tools and techniques. I'll show you. This is about Leeds packet. If you have not been to Leeds, there are two campuses. That's the Headingley campus, and this is the city campus. Apparently, Leeds tend to produce more CO than Oxford and other universities. Again, this is the data. Okay, so these are the areas of research that we do: AI, machine learning, IT, sustainability, service-oriented architecture. That's one area, and some of the projects. So I'll just quickly move on. Okay, the two case studies I looked at when I started looking at how I apply my framework to Fintech. So I was looking for academic reference. There was one reported by Ant Financial Service in China. They developed the hill, the Mount Everest, above 5,000 meters. Obviously, no signal, no Wi-Fi, no 2G. Yeah. So, how did they do? There's no currency to get it. So apparently, the Ant Financial have used machine learning techniques to improve loan process and improve buy and sell in the t-shirt. So they use QR code to approve, and then offline payment, and then they shop probably send them by post and so on. So that motivated me to look at how the technology has been applied in Fintech, and we can see now we more and more use mobile e-commerce for our banking, which is quite convenient. Going to bank, it's already high street banks closed, so we started to trust. So term started to be how we build trust. So if you compare, another motivation why I started this work. If you remember 2000, I used to work for a Philips research in Surrey. So year 2000, .com boost, started to, and then suddenly in 2006, there's a burst, and even students didn't get a job. So when they did the analysis, mainly the .com boom was by the banking sector, investment sector, because they wanted to move the banking, close down the high street banking, and that's the trigger. That was the trigger started to boom the internet. But in the analysis, what they discovered was that none of those companies used any sort of value-driven approach. And same 50 years of software engineering failures, some of you probably know, is that again, is most of the failed software or lack of budget or over the budget is due to lack of applied value-driven approach. That's a software engineering approach, value-driven approach. Now, same even recent case with the Boeing 737 MAX, similar requirements failure, discovered and test requirement considerably. So this is one of the case study. And then I started to look at what is happening in the UK. So from there, Chinese financial industry, they discovered there are major challenges, customer-driven versus business-driven. There's a low-cost versus cost category. How we move fast in applying the technology to help people to enjoy. But at the same time, how do we build the trust and how we deliver in an intelligent way. That was that. And they discovered these 5 technologies, basics or ABC. So blockchain, AI, security, IoT, and the cloud computing. Now, in blockchain, I probably wouldn't recommend the whole process of blockchain, but this concept of smart contract, which is what everyone seems to advise in the design. If you apply the principle of smart contract in the requirements level, then which is already proven, so which might benefit us, and that's one of my own discovery from these case studies. So that was the Chinese financial industry's findings. Only they are quite popular, Design Financial. There's another 2 companies. They approved the loan so quickly with photo taken, insurance claim in particular. And they look at the photo, they use the AI, machine learning techniques to, what's your history and what's the nature of fault and similar fault and so on. They use really machine learning based approach. Apparently, most of the customers are going to somehow satisfied. There was no issue of dissatisfaction. Right? So this is the UK sector state of the art. UK seems to, again, it was also on BBC News and Sunday when I was doing this presentation that more and more are first using mobile banking, which is true. There are more than 1,600 Fintech firms already in place, and apparently they wanted to double this, or they will double, not they wanted to double, because there's more investment is going into the financial sector. There's going to double this by 2030. So our given from before, and that was the prediction. And UK, again, obviously, are the economies. First on financial investment, digital economy. There is a 42% of adoption rate. You can say even in this room using mobile commerce, more than I would say 70% of us. So there is a quite is the UK State of the Nation, the government case study. It also recommends the number of technology that might be soon be applied in the financial sectors. Things like, again, see $35 billion going into the Fintech. And again, they question, where are we going to find these skills? Skills in financial sector, which is another challenge. In the university, we can't educate them. So where do they get the domain knowledge? And which is what basically they wanted to achieve. There is workforce by 29% by 2022. They recommend from their investigation the future of technology trends will be blockchain, application of identity management and voting systems. Yeah, e-voting and so on. Drones may be applied in the insurance claims. More and more we have a natural disaster happening everywhere. So in those situations, how do we help them and then mobile banking, which we already enjoy the mobile banking. There could be a different type of IoT. That's another IoT is another big technological revolution is ongoing. You can from remotely you can ask your fridge to defrost whatever you want. It's going very fast. And the IBM, one of my colleagues in IBM, he was saying they use AI to washing machine which will determine, because not all cloth needs 40 degree or an hour and a half. So apparently the washing machine will determine individually how long it needs, and so there's so much again going on. There's 3D printing robots, virtual reality, AR, again already is starting to emerge. I met a company in Leeds, they're actually doing very interesting work on the house design. So you can actually visually see with their AR and see how your house will, new property will look like. So this very interesting type of application is emerging. So this is the UK's finding, which blockchain might evolve. In particular, in my opinion, the smart contract aspect of the design will evolve, will be more applicable. Deep learning and natural language processing again is on the emerge. I mean, everybody has a Google assistant, a speaker, and so on. You can talk, and it's helping people in need. And AI assessment of claims and risk assessment will be applicable. I think I will skip this because you all know what is service driven, because the future is going to be service driven. So I'll show you maybe quickly, just to refresh your knowledge. So this is what 20 years ago. Yeah, you remember using a PC, trying to connect your camera, wouldn't connect, or you have to restart the Windows, yeah, to be able to connect. You can remember. By the way, with this, the Trans of Trust window have discovered 21 security loopholes left in the DOS in 2012. Okay, so this is kind of 10 years ago. So we were with USB, we can connect, plug and play. That's concept. So I'll run over quickly. Okay, now with 5G, we can do services to connect, not the data, services to connect. So which means from your mobile, you can invoke a different type of services. That's the meaning. So the services are going to connect. We didn't have the technology. Now the 5G apparently will allow us to connect the services, which means more multitude of data. So that was the just quick recap of things. So this is what might do. Smart cities, you might offer smart cities, smart home. So everything is going to be seamlessly integrated, and we're going to have services connected. So your home, you could invoke different types of services in case of emergency and so on, not always to the police. Yeah? So that sort of technology. However, in the recent interview, the National Cyber Security Center Director Levy, I guess, he was speaking on 5G Click. There was a 5G special program a few weeks back, and he was saying, yes, you know about the government political scheme, but the technology is here. Couldn't stop, can't stop. However, he's saying, yes, it is going to be interesting. However, we need to be more applied value. That's the motivation for my talk. Okay, simple paradigm of service computing. It's not traditional layered architecture. It's service request paradigm, which is quite useful. You can apply to any level of your architecture if you stick to the traditional. Which is the interesting thing about service computing. You can still keep your traditional system working, but you can slowly integrate them with service computing to move on to integrate with the rest of the world. Basic architecture, 3-layer, I will skip them. Okay, so these were in my framework through for cloud computing. The requirements, same traditional requirements of design, you can't escape from that traditional method. But what method that can apply, which is quite quick to validate certain resource requirement, which is going to be on the cloud. So therefore, I started to look at BPMN, business process modeling notation, which does allow us to quickly specify. That's the interesting part. It's not a thorough specification in the traditional sense, but at the first level, you can say how much resource they are migrating to a particular cloud, what are the resource constraints are needed, which you can quite easily check and validate within a couple of hours. So there's quite a number of simulation tools. You can, once you know the notations, simple notations, you can do business decision making and so on. So all that can be done very quickly and validate your constraints, requirements constraints, which are the key element in the first level of requirement. So that's my model. We do that with the case study on this CAS, service-oriented applications. So they do proper service requirements, BPMN. You can quickly simulate. You can even develop a prototype to show how you can do. You can develop a profile of your load constraints and quickly see what are the resource constraints, cost, improving cost. So that's the part of the first requirements engineering principles, and then you can move on to detailed traditional requirements engineering methods to meet. In the design level, I looked at, although I am more component-based modeling expertise, I looked at for service computing world, I looked at the SOAML, which is another new modeling notations, has been already developed. Now part of very well-known software tools, which allows you to do the detailed design from the perspective of the customer. So which is what is they say SOAML evolved, and then you could do the implementation and okay. So this is the whole package of the framework, which I'm not going to go into detail. So the methods and design principle, the process, the reference architecture. There are quite a number of open source tools as well as the standard tools from Visual Paradigm and so on. There's a number of services which we've been working on, software engineering as a service. So I looked at the traditional software engineering. How do we help the younger generation in terms of, for example, cost estimation or part of the software engineering applications that they can use. There are quite a number of adoption models which we have developed and the evaluation. So the application is one of these. So I did look at reuse of, these are the key design principles. So basically one of the principles is that we know wealth of knowledge last 50 years requirements of design. So various parts. There are now quite a number of open source data available. For example, for a browser, another case we looked at for a browser security vulnerabilities, there is quite open source data, and which gives us, once we do machine learning, we can visualize where are the vulnerabilities that was there last 10 years. So that gives us sort of opportunity to learn, and maybe we can refine the requirements quite quickly. So that's where the application of machine learning comes into earlier part of the life cycle. So not yet. So again, abstraction, lightweight versus heavyweight. So there are already well-proven abstraction emerged, components, microservices, containers, all in the cloud, becoming more and more popular, and people starting to use. Smart contract with blockchain technology concept is quite good. So there's also there's a comparative evaluation with the well-known architecture models, which is the video. So these are the level of abstraction, from objects, components, service components to microservices to packaging, virtual machines, which is another abstraction is being established. That's how the cloud is merged. So it's all question of as an architect, where each type of level of granularity indeed in the architecture, which is decision to be made. Serverless programming is another area. So you all know the 3D layered concept. And again, this big question of designing with the granularity, type of abstraction used at each level of the layer. That's a simple example of a component model which I did for a few years back. You can see the component model, and interesting thing is that it gives you different types of interface, a wider interface, and the requires the semi-arc is the requires interface. All basically well-established notations after maybe 20 years of expertise built those notations. I found it quite useful. You can design your strategies in a matter of hours, and you can see what are the services you want to make it visible to outside world. That's where the component-based level of abstraction comes in. Now, which is again natural extension to service service computing. Because in the service computing, instead of in the traditional one, you are going to connect them through procedure call, whereas here you are going to connect them through messages. That's where the foundation becomes much stronger. Then you are pretty much guaranteed that it becomes connected to that. Okay, so that was again in the prediction. There are well-established mathematical modeling applied in the financial industry. I've got the expertise, but there are well-known methodologies that exist as mathematically proven, and that's what people they use. This is my reference architecture. It's a generic. I looked at various architecture, and I wanted to make it as simple as can be in the service world. Even when we design the applications which are going into the cloud, I truly believe it has to be service-oriented, because you are moving to service-oriented. You don't want to just export your package, which is non-service-oriented. So, but there are simple architecture at the top level, what we call orchestration layer or coordination layer, where different types of services in the enterprise world can connect and communicate. The interesting change is that they self-discover new service depending on the environment. And then the business service that you can decide what are the business services and so on. So I have more strict specification after the business process modeling to categorize the task in terms of utility coordination service, so that you know where the architecture they are going to be placed. Okay. So I'll just show you, and then you work on traditional the architecture. And that's my classification of the services. This is a simple example of the banking application, customer banking, mobile banking architecture example. I'll show you. So this is the cognitive architecture which I mentioned. What's in the future, right? IBM already has evolved and deployed apparently. That is based on the neo synaptic cores, based on so that's the. So I'll move on this domain. So these are the. Okay. So that's the simple financial services that I showed in the architecture. This is the BPMN version of it. So once you know this is actually, you should do this and to the architecture. I'm showing the other way around. So you should be doing business process modeling where you can involve every constraints that you can think of, and you can see each process. You can again define, they call it notion of pool and lanes. You can map your architecture according to the pools and lanes, and you can quickly get a simulation version of your services. In particular, the cost and the resources, how much it will consume, you know how that's going to happen with your new process that you merge. Now, this is the newly drawn. My question was, there already exist, for example, loan processes. So there's, well-known banking sector has open source data. How I'm going to validate my process as well as learn from their 10 years of experience. that's where my machine learning comes to the process, what I call process management, not data management, process management. I can define and verify before I move on to the next stage. With more learning from knowledge, with the use of the technology. And so then the next step, so that's my final. So these are all your traditional quality of service and think of. So this is the business mining data for a Dutch bank, which is open source. They studied from 10 years until 2017. They offered actually a business intelligence challenge to a group of communities. If you find what is in those processes, they would award something. So I used machine learning to learn my banking loan process to define my requirements. So this is what I ended up in learning out of that experiment. So use the existing data and do the process mining through machine learning, and you can define your requirement process. Add, verify, define, and so on. So we used Azure ML, which is quite easy. I'm not an expert in ML. I'm a software architect here, or software engineer. So well proven. It's well proven Azure machine learning techniques. We don't need to be expertise. It's all there out in the cloud, and it's even free to use at some time. And we use the Azure ML, which is basically this is what we got. Machine learning, analytics, performance and process accuracy, and we prove requirements. So this is what the data we received. I'm not sure if I can see or if I can enlarge. But you can see that's the data we split into the machine learning model. It's quite simplified, right? In the Azure ML, you train 10% of the data and use 70% of the test. This is what you will get. You can validate your requirements process, the accuracy of your process, and then discover new process. So quite simple, and then define, go back and define. Okay, here this I conclude. So Fintech technology is emerging, and they need skill for Fintech applications. And my discovery was some of those technologies can be quite useful for us to define traditional applications. And smart contract with the blockchain concept will be quite useful again. Technology to use. With that, I thank you very much.